Hey everyone, and welcome back to the series of Python. In the last session, we understood what data types are and saw their classification. In this session, we will learn about numeric data type or numbers. Let's get started. So in the last session, we saw this classification chart, right? Where we came to know that Python data types are divided into 5 broad categories. First number, second dictionary, then boolean, then set, and then sequence. Now in this session, we will understand about numeric data type or numbers in detail. Now as the name suggests, numeric data type consists of numbers, but again, they are itself divided into integers, float, and complex. Let's understand all of them in detail. First of all, integers. Integers are basically numbers without decimal points. Basically, integers are the numbers that have no decimal points. For example, 1, 23, 54, and so on and so forth. Even it can be some negative numbers like -3, -5, or it can be 0, or it can be any positive number like 999, etc. Any number that doesn't have a decimal point comes under integer. And what about this number 5.9, let's say? No, this will not be an integer because it has a decimal point. Now let's see this action in IDLE. So let's make a variable. Let's say a is equal to 32, and obviously you would have understood until now that 32 is an integer, right? Because it has no decimal point. So if we say print and then type a, it should print the type of a, right? As you probably already be knowing. Yep, we got class int, and int stands for integer. Now one thing I would say over here, in interactive mode we actually don't even need to use print to display anything on the screen. We can just write that thing itself without any command or function like print. For example, if we have to display, let's say 5, we can just say 5 and we'll get 5. I know this might be seeming magical, but this is true. But it's a good practice to use print function if possible. This thing is only possible in interactive mode. So it's not possible in the script mode where we would be writing actual programs. So it's a good practice to use the print function, although for testing purposes, like let's say we have to check the type of a. We don't need to say print and then inside of this type. We can just say type a and it will display this thing. So for testing purposes, we can just use this method of without using print function. So now we have a is equal to 32 and it's an integer, right? As we already tested that. So now what I am going to do is I am going to show you some amazing things or some operations that we can perform on integers. For example, let's say we make another variable and let's say we we can store obviously 65 in this, but instead of storing 65, let's say we used plus sign and then 87 like that. And what do you think will happen? What is this? It's actually nothing but an integer. So how does that work? Let me show you. Let's say print b. We got 152. Now you might have already guessed these two numbers have been added together and we got 152 as the result. So this plus thing here is called an operator, and an operator is basically nothing but something that performs an action on some given values, and those values are 65 and 87 over here. So this plus operator added these two values and then that value is stored in a variable called b, and then when we displayed out that variable, we got 152 as the result, because 152 uh, has come after adding these two numbers. So along with addition, we can also perform some other actions, some other operations, like let's say subtraction. 76 minus 54, 76 minus 54, and let's do print C, or we can just say print all C also without using print, because in interactive mode we don't need to use print, as I already said. We got 22, right? Okay, now let's see what happens when I try to multiply this. So first of all, where is the multiplication sign? What is the multiplication sign on the keyboard? Now there is something that looks like a multiplication sign, but that is not an actual multiplication sign. It's X on the keyboard, right? We can say 56 times 5, but this will not work. Python will not treat X as a multiplication sign. So what we can use here? Well, for multiplication, we use an operator called as uh, we use an operator that looks like a star on the keyboard. It's actually called asterisk. And let's say we want to multiply this by 2, and then let's do print d, and we got 112 or 112, which is absolutely right. So for multiplication, we use star or asterisk. Now let's see for division. For division, we have something like this, a slash sign, you can say, or divided by sign. So let's say we want to divide 4 with by 2, so we will say 4 divided by 2, and let's say e, and we got 2.0. Now this might seem a little bit confusing to you. Why we have 0.0 over here, right? Until now we didn't have that. So you will understand that properly later on. For now, just understand, whenever we do division, we got a decimal value, either it's actual decimal or not. Let's say we do this, e is equal to 5 divided by 2, and then e, it's an actual decimal over here, because we are getting 2.5, but this is just 2. Then why did we get 0.0 over here? It was not necessary, right? So this happens in division operator. Even if it is not necessary, it always returns a value with decimal point. So now these are the basic things that we can perform on integers. Now if you want to look for functions that you can use on integers, you can just do this dir, then e, and dir is basically nothing but a function name, which is used for which is basically used for checking the list of functions that you can use on any type of data. For example, integer over here, e is an integer, so it is showing all the things that we can use on integer. So this is the use of dir function. Don't worry if you don't understand this right now. I was just showing you. If you want to check the functions that you can use on integer, you can just go ahead and look at that using dir function. Now let's go ahead and let's move ahead now. The next one is float. Now what is float? Numbers having decimal points come under float data type. The numbers that have decimal points, unlike integers, come under float data type. They are also called as floating point numbers. Numbers that have decimal points, for example 2.3, 76.543, or any of the things, even 65.0, which seems like an integer, right? It's the same as 65. So 65 is an integer. Obviously it's an integer. If you do this, let's say, just a second, let's say type 65. We got class int. So if we do type 65, we got class int because 65 is an integer. But when I do 65.0, can you guess what we are going to be getting? We are going to get class float. It's because it's a floating point number or a decimal number, even though this decimal point doesn't matter here because the values of both the things are same, but Python treats these two data as different, not in value perspective but in type perspective. So it can be something like this also, where it's just 0 which is written after the point, doesn't matter. For example, 1.0 is also a floating point number. 3.4 is also a floating point number. It can be even negatives like negative 3.5 or anything like that. Now as the integer, we can also do the same thing on floating point number, the same operations. Let me just show you. And instead of using variables, this time I'm just going to display it on the screen. Let's use print function 4.5, let's say, which is the floating point number, plus 3.4. We got 7.9. Obviously it's expected, right? If we add 4.5 and 3.4, we are going to be getting 7.9. But the main thing to observe over here is both the things are float, and we got float as the result. What if we do like this, 4.5 plus 3? So one of the things over here is float, but the next one is an integer. What do you think will happen? We are going to be getting a float because the result over here will come in decimal. So Python will convert the whole result into float data type. Python is very flexible in type conversion. Next up, let's say 4.5 multiplied by 3. Again, we are multiplying it with an integer, but still we are going to be getting a float value. Now, the division thing. Now let me just show you one more thing. 1.2 plus. Now what happens if I do 1.2 minus 0.2? The result is obviously an integer if you notice properly. In this case, when we subtract 1.2 and 0.2, we will get 1, right? But in Python, we are still going to be getting 1.0 and not 1. The reason is one of the data types, actually both of the data types over here are float. So Python will give the result as float also. And even one of the data types will be float, the result will be float, right? That's how things work. You will understand much more while practicing things. The same thing can be done in division. For example, 5.2 divided by 4, or you can just divide by any floating point also. We got this, which is also a floating point number. And for division, it's actually a special case. Whenever we divide even an integer like 4 divided by 2, it will still be floating point value, which we got in the previous example as well, right? The reason behind it is Python just doesn't want to confuse us. It has set a rule in division operator that whenever we divide anything, whether it's an integer or a float, we are always going to be getting an a floating point value, right? So for example, let's say we divided 5 divided by 2. In this case, we are going to be getting a floating point value, right? Because the division result will be a decimal value. But in this case, the division result was not a decimal value. But Python just has made a rule for division operator that we will always get a floating point value while using the division operator. Now let's look at complex data type. If you have learned maths, you might be knowing about complex numbers, but if not, do not worry. I will explain what it is in very short over here, and if it still doesn't help you, you can look on internet about it, because there are thousands of resources available for you for 100% free. But if it still doesn't seem to clear you, don't worry. Complex numbers would be very rarely used in this series, so you should be fine. Now let's understand about complex numbers in short. So in basic maths, you at least have studied about numbers, right? For example, 1, 2, 3, 4. So let's say we have to calculate the square root of 4. It's very easy, right? We can just say 2. Now this is simple, but what if we do something like this? Let's say this time we have to calculate the square root of negative 4. Can we say negative 2? No. The reason behind this is the square of negative 2 is also 4. Right? If we do negative 2 square, this will be 4. And if we do square of 2, this will also be 4. Whether it's negative or positive, it doesn't matter. It will always be 4. So, uh, what value should be over here if it's not negative 2 to fulfill this demand? That is, to fulfill the square root of negative 4. There seems to be having no real value in existence, right? We can only think of two things, negative 2 or positive 2. If both of those are not acceptable, we can't do anything. We have no value of square root of negative 4, right? There's no real number existing that satisfies this square root. So in this situation, we get a concept of imaginary numbers, right? Like this. Sorry, this session is getting a little bit late. Now, in let's say we have to calculate the square root of. Let's say we have to calculate the square root of negative 1. So we again don't know what will be, because if we say 1, the square of 1 is 1. So this doesn't satisfy this. If you have learned math, you might be understanding this. If we say negative 1, again the square of negative 1 will be 1. So it still doesn't satisfy. 1 and negative 1 both can't be the correct answer. So just a second, let me just get rid of these things. Now, uh, mathematicians have come with a imaginary thing called I, let's say. Okay? Which is also known as iota. Okay, so basically square root of negative 1 is equal to I. We can say this is an imaginary term. This doesn't exist in real life. This is just an imagination. It was created for us because we had to do some calculations like this, right? Just because of this thing we can calculate the square root of negative 4. Okay, so we can write this as square root of 4 into negative 1, and then this will be what? 2i, right? So the square root of negative 4 will be 2i. Now this 2i doesn't exist in reality, because I doesn't exist in reality, because the value of I is root negative 1, which doesn't exist. So now this is the concept of imaginary numbers. Now what is complex, right? That's what we have to understand. The complex number is nothing but the combination of real and imaginary, right? So now let's see over here. Numbers having real and imaginary parts come under complex data type. Okay, so In maths we use I, but in Python we use J for representing imaginary numbers. So let's say we have to make a complex number. Let's say the variable name is com, and let's create a number called 3 plus 6j. Now what 3 plus 6j means over here? 3 plus 6j is a complex number which has 3 as the real part and 6j as the imaginary part, right? We know that complex numbers have real and imaginary parts both. The format of a complex number is real plus imaginary j, which I just wrote over here. Real plus imaginary part and then j. Now if we try to print complex number, we are going to get something like this. So this is complex. If you don't understand it properly, don't worry, this is not much of a requirement. So this is it for this session. This was kind of a long session, sorry about that. Hopefully you understood about int, float and complex data types. If you have any doubt, please feel free to comment in the comment section below. Thank you so much for watching, and I'll see you next time. Goodbye.